on. Let's see. All right, and I'm going to share my screen. Oh, shoot, I shared the wrong screen here. Well, whatever, it doesn't really matter. Well, yeah, it is. You don't want to see all that stuff. Okay, yeah, here you go. So this is what I found out, right? What I found out was this. The subscription level that we have only allows what, well, that's a little big. Only allows 5 like licenses for access. And what does that really mean? Well, the licensing here, it dictates your level of what you can do in Azure. So what I mean by that is, you know, ideally we should all be Visual Studio subscribers, but that's like it's like $49 a month, and then I think it's like $12 per seat, so $12 per user per month. So it's really not economical. So what they have is this basic level, which is pretty reasonably priced. When we get into CSCI 305 and we focus on development operations, we will need everyone to be at this basic user access level. So I only have 5 licenses, right? Well, obviously there's more than 5 people in the classroom, but what we do have is we have less than 5 teams, right? So what we can do, and what I did last night was I set up accounts. So here you'll see that like Dana 29-3, well, Dana 29-03 at defiance.edu, that has a subscription. Dana 2901 basic. So the only one I couldn't really get was 04. So what I did was I just used this account. So the last team, whoever that happens to be, you're going to just be T user. What this means is when you log into Visual Studio, right, and that video has you logging in to your account, which you can do that by all means, you can do that. You just won't be able to tie it in and have your own private repo. Well, I think you can have a private repo, but I don't think you can share it. So here's what I'm thinking that's going to be the easiest to do. For each team, you'll have assigned, like, for example, this account here, this the green, Dana 29-02. So when you sign into Visual Studio, you'll sign in with that username or that login for your team. And then you'll use that because you'll have access to your repo. And again, your repo is this thing.
Are you showing stuff on your screen? Because we only see ourselves on your screen.
Oh, come on, man.
Yeah.
Thank you.
Yep.
Oh, that's no good. Here. Yeah, when you see that, when you see me, okay, they're cool. I see the red box. They have a red box, like, so it should tell me. You want control, Ben? Sorry, I have to deny you. Okay, so let's step back a minute. Thanks for pointing that out. Like here's our organization, right? Defiance-edu. And what I'm talking about with the licensing is this stuff. Yeah, because you wouldn't have seen any of this. If I go under here, users, right? So the access level, that says that, okay, you have basic, Visual Studio subscriber, and then you have stakeholder. So when you log in, you're actually, even though I set you as this, there's no license for that. So what will happen is you'll get kicked down to a stakeholder. Again, don't worry about what those terms mean. That is all in a different class. What it really means, or what's important for us, is that your username you won't use to sign into Visual Studio if you are working on, in your team, working on your assignments, okay? What you'll use instead will be these type of accounts. These, and if you remember these from last semester, these are the ones that, you know, you can sign in through Chrome and all that stuff. these are like full-fledged email accounts, like accounts in our domain, but I'm able to assign 5 basic licenses. Well, really 4, right? Because we have 4 teams. So that's what we're talking about. So when you sign in, and again, now that we can see this, when you sign in here, you can see that I'm signed in with my name. What you're going to do is if you're working on that team project, you'll sign in with that team username. I haven't sent those out yet. And again, like I said, don't worry. We have plenty of time. We have a lot of content to cover before we even get to this point of working on assignments. So, play around with it. I'll get you those usernames and passwords when I can get a minute. And I also need to find out, there's still 2 teams that yet need to be formed. So I don't want to say y'all have to figure that out, but everyone's gonna have to be on a team. All right. So what? Well, part of the assignment was to do this, which is, between, boy, I got to go back in the time machine. Tuesday and today, you wanted to get into, open up Visual Studio and then make sure you can sign in. Well, now, in addition to that, you're going to need to sign in with one of these accounts, right? So if you're ready for that, if you're ready to do that, shoot me an email and then we'll get that set up. And again, the only problem with this is, and actually to be a little bit more clearer, is that only one person at a time should be logged in with this account actually working. Because if you are working on your main branch or if you're working on your code and then someone else comes in and is working on the same code, how does that stuff get synchronized, right? I'll talk more about that as we go along, but it's pretty much a straightforward process. You'll just have to know and communicate with your other team member or members who's logging in and working on what time. Hey, I'm going to work, I've got time on Thursday from 11 to 2. Okay, great. Then Thursday, 11 to 2, you make sure everyone in your team knows that you're working on it. You log into Visual Studio with this account, do your work, and then when you're finished, you'll save your work, and then the next person can go to town, right? So again, I will go over all that stuff as we need to when we get there. But I kind of think most of that was in the video, but whatever. We'll do it again. All right, so any questions with that? Any thoughts on that? Any problems that you guys see?
I mean, I just spent a lot of time trying to get into it, and then I realized, well, something's probably wrong because I've tried to verify my email 5 times, and then it didn't work out.
Okay, yeah, because again, it's trying to probably verify you at this level. So what I can do then is just change the access level. And like I said, stakeholder, that'll be fine. You kind of have unlimited stakeholders, right? And so I will just go through and shoot me an email. Let me know where you're at. Again, if you're ready to jump up to, if you're ready to jump up to getting on this team. Now, I did put you as a stakeholder in your team. So Jessica, you're a good example here. I put you on the first team, so you have access with your account as a stakeholder. And it would be interesting, you'll get a little preview of what the difference there is between someone that actually has access as a contributor versus someone that is just someone there that kind of sees things. But at any rate, you'll see all these users like this first one. If I go here, yes, they're basic, but you can see they're actually project administrators as far as their level, And again, we'll go over all this not garbage. We'll go over all this stuff in another class, but I should have. And again, honestly, I went through and did all this over the summer. I went through, made sure everything was good, but I didn't realize there was a cap of 5. So that's where I was kind of stressing out and looking at pricing plans to see if I could put something together. But I just can't. I can't justify the cost based on the amount of work that we're doing in there. But as we move into other classes, it's well justified. All right. Anything else, gang, for the good of the group?
Yeah, I just gotta say, on my PC, everything is just like crashing. So when I requested control earlier, I didn't know what I was clicking, so I couldn't. It was just black screen. So
Okay, now
they're
you
going
mean
to
your
my
P?
phone and it's really small.
Oh, you mean earlier?
Yeah, I have to. Yeah, that's it.
Okay. Well,
Yeah.
is everything fine now?
Well, not on my computer, but I have it up on my phone.
Okay. So, because I think I can see, you're in the lab, right?
Yeah.
Hmm. I'm gonna have to look at that because I did log into, again, I can't test
Oh,
all the computers, but this
it's
should be
my
working.
it's my laptop. I should say, not the one here. It's my laptop. It's just being really
Well, that,
bad.
well, and that's a good question because not a good question, but I'm glad you brought that up because we should be able to at least take care of our own. And what I mean by that is like us as CS people. So
Yeah.
again, that's why I'm like, okay, ACM, part of that is there's already a student club called DCPC, and we should be able to talk amongst one another to kind of figure out like things like that. Yeah, worst case scenario, I mean, maybe we can just run some kind of diagnostics that's built into the system so we can determine if there is like maybe a hard drive failure, maybe there's an issue with the memory. So there should be something that we could run to test the diagnostics of that, the hardware. But 9 times out of 10, what happens? It's usually software related. And at the end of the day, I know I did it with my laptop over the summer, which is I just reimaged it. I just started fresh, wiped everything out, and hey, my laptop works like a champ. So
Very
again,
good idea.
yeah, so we should have those conversations. And if anybody wants to, and that's part of the ACM thing is like I want to make like a subcategory in there, like, hey, hardware people, or like help people with computer issues. And I think again, we should focus on ourselves first, make sure we're solid, and then we can help other students too. So thanks for bringing it up.
No problem.
Anything else, guys?
When I went in earlier at like 9:30 I went into the lab on the computers, and none of the computers, like I tried 2 different computers and none of them would let me sign on.
Had you ever signed on?
I mean, I signed in like last semester.
Okay. So remember, the thing with signing the computers this semester is that, and I can bring this up here. Remember, it's this.
Isn't it back to the default password or something?
Yes.
But
So
that's so weird because the esports computer takes my old password. Is that a different domain?
yeah. So everything's
Oh.
different, right? So we're like on our own domain. I just made the usernames the same, so it would be easier for you guys to at least remember that. But now we're talking about passwords being different in Dana 29, passwords being different when you log into Gmail, and passwords different when you actually log into Visual Studio or any kind of Office 365 products. So it's like this, these could all be brought under one umbrella, if you will. But we're just not there because honestly, the IT department's pretty small here and it's not in place. But so just, yeah, for the lab Dana 29, put that password in and it'll prompt you to change it. And then you can change it to the same one that you use in the esports arena.
Awesome, thank you.
Sure. Cool. At least I can answer these questions. All right, guys. I'm going to do some moving around here if this will work. I'm going to
Should
go
we
over
just,
here.
while we're in a video call, should we just hash out teams right now? Take like 30
Sure.
seconds.
What do you want to do?
Should we just you said some people are in teams. Should we just hash out who's where right now?
Well, the only ones that aren't in a team are Michaela, Ben, you, and Parker. So there's 4 people. So amongst yourselves, I don't want to say figure it out, but that's what you have to work with.
And then there's
Me and
another team of
Michaela
3. I mean, I guess I can be in a team with you guys. I'll be like a team of 3, and then is
There's
there another
already,
team of 3?
yeah, so there's only 4 people left, not in a team, so we just need to pair them up.
Michaela and I were gonna be in a team together.
And then I
Yep.
guess
I was
Parker, do you want to
lazy
be
and
in a team
didn't
with
email.
me?
Good. It's a good match. I think those teams will work well. Again, I wanted you to pick your own teams so that way, you know, I mean, sometimes there's like people that maybe I don't want to say you don't like, but you're just not jiving with, and I'm not going to force anyone to do that. But yeah, because that's what you have to do, you know, typically in a job, right? Sometimes you're going to be working with people that, I know the last place I was at, boy, you know, there was some nice people, but the vast majority of them, so cool. All right, then. Yeah, so we got that figured out. Shoot me an email, Michaela, Ben, Devin, and Parker, to let me know, so that way I know to go add you in over here to the Azure business and get the permissions all right and that kind of stuff. Cool. All right, guys. So again, you know, a lot of this is, unfortunately, you know, some of it is review from last semester as far as content, but it is all important and it's really great stuff. You know, the beginning of this chapter really talks about some higher level things before we really look at examples, but I do have a lot of examples that I want to show you. And so without further ado, let's really, yep, here we go. So let me show this from the current slide on what monitor? I mean, what monitor are you? Is it the primary? I don't know. Let's see. Hey, it worked. Okay, cool. So I didn't say okay, Google. Go away. No, you can't do anything for me.
Okay, I'll stop.
Thanks. I mean, it even works without the lock on. I mean, I like it sometimes, but I guess I slur a lot, and she thinks I say her name all the time. Okay, guys, this is where we left off. Object-oriented programming, the terminology. We said that, hey, there's this difference. There's some, you know, we talk about variables and these kind of things before and data types, right? Well, now we're talking about classes. So when we think of, in our mind, the word class, we think really of a data type. So think of this, you know, the word class here really as like an int, a bool, it's a data type, right? It's a class. Then when we create, like how we would create a variable like int number, we really instead are creating class object. So we're creating, you know, if our class happens to be called, and I think I used the class that's kind of the deep standard. I said, you know, the name of the class is rectangle. And then when you have an instance of that class, that is an object. So in the past, we've used this word like variable. Well, really, it's an object. The difference there, and this is an important one, and again, the book goes into detail on this, but the difference there is that your object has a lot more stuff in it. It can do a lot more things than what your typical variable can do, right? So again, important to know the terms, important to know what they are, because you'll hear it all the time. Okay. Yeah, that's exactly right. And then we said about the importance of, you know, really naming the objects like appropriately. This gives you a good example of this idea of classes and objects. A nice little thing here. A class is like a blueprint. It's this outline, right, of what things, you know, your objects that you create, what they should look like. And that's it, right? The blueprint describes a house, and then you have instances of house. Now, the interesting thing here and the kind of next level of thinking is what? What do you think? Do you think that well, here's a relationship. Did anyone read the chapter to be like, talk about this a little bit? Or you just want to hear me flap on?
I read most of it.
All right. So what's interesting here? I mean, can we talk about some relationships here between those houses, the three at the bottom, and then the actual blueprint?
So like, I think in this example, like the house is the object, and you could like name your house, and that would probably be an instance of the class. But then like the house plan and like the living room and the bedroom, I feel like those are kind of supposed to be the member variables that kind of go inside of it.
Yes. Hey, that's perfect. What about some other observations as far as, again, the relationship between that blueprint and the houses? And I'll lead into this a little bit. Do you think, I mean, I don't know, maybe a lot of you haven't, I don't want to say, built houses, right? I actually had a job where that, like, I was kind of like knew a lot about it. But I guess the point is that even though these houses all look the same, what do you think about, what if this house, and I'll just color it in a little bit, see how good I can color here. What are you seeing here?
Even if they're like all the same house, they're gonna have different addresses.
Yes, they're going to have different addresses, and that's a really good observation. I didn't even think about that. But you see how they're a little bit different, right? So you have these, and again, that's great, Michaela. Why, I want you guys to kind of talk a little bit, or maybe articulate a little bit about what's going on here, because you use some really good words there, terminology about talking about the relationship that, hey, these houses, they're all instances of the class, and you're absolutely right. And then what's going to happen, and what we're going to see here, just like with these three houses, they don't all have to be identical. They can have some changes because, right? What if up here, your living room, you could even maybe change the size of it. You could paint it a different color. Trying to think about other things. You could even decorate it differently, right? They're not going to be identical. So those things inside, yeah, those are going to be those member variables, and those are all going to be things that you can change, right? So we're going to talk about all that stuff. You're going to see it. But again, I think this is a good illustration. Gaddis does a really good job talking about this in a text. So
So is that all the same class? The houses are one.
Yep.
The
So-
houses,
class,
yeah.
and you can
they're
change them?
A
instances
class
of
can
the
give you
object,
different
yeah.
objects.
So basically, like the blueprint right there, think of it as like copying and paste it onto those three houses. So like the blueprint, that's the class, but the object is the actual houses that you're pasting onto it.
Well,
And you can put whatever you want inside, kind of.
it's an instance of that class. So it's like
Yeah.
the blueprint exists there. So don't go the other way around, because once the object's there and created, it doesn't like kind of go back to the class. It's derived from the class, right? So it's like the class is there, it's sitting there, and then we can make different objects that again can have different properties and different methods and stuff, member functions that we'll talk about. Good, really good. And again, fantastic. And that's what I said. This is the whole point. We need to take some time to work through this, to really understand it, because otherwise, in future classes, I think we're going to have problems. Actually, I know we will. Okay. So now, as far as we move from this abstract a little bit to talking about some of these things, right? So when we're talking about those member variables, we can also refer to those as attributes, right? Now, I'll tell you, methods or behaviors in other programming languages, the procedures an object performs are going to be called methods, right? In C++, you can see right here what we call them. Who wants to shout out the answer on that one?
Functions.
Yeah, it's a member function. So, we typically talk more general like functions, but it's a member, right, of that object. So it's a member function, not a big deal. And then we have, like you said, Michaela, member variables. But do you see how the terminology becomes kind of a little, I don't want to say muddled, but again, the point is to know that these member functions actually do something. And even greater is you can see this: set, get, get, get. So you know by looking at those words that one of those is setting some things, doing something with maybe the attributes or the whatever happens to be passed into that function. Well, you can see right here what's going to be changed, right? You're going to be setting that variable, right? Again, then we can talk about, well, is it the, sorry, my brain's a little, oof. But at any rate, where I'm getting, you can see I'm returning something. So you can see this is structured very well. And based on the return type of that member function, I could really see if it's going to be something that's going to set a value, or I expect to get something back, right? It's returning something. At any rate, high level stuff here. Yep. Again, when we talk about attributes, really, we're just talking about variables of our class is all that is. Now, with this right here, looking at the member variables and the member functions, what do you think, what class would this go to? What would be like a way to, what would you call this stuff? A class for what? Who?
Rectangle.
Exactly. And it's in the textbook too. So if you took a look at the textbook, you would know that. But yeah, doesn't it make sense? You have a length, you have a width. It looks like it defines what a rectangle would be. And this again is why it's important with the naming, because I should be able to look at that and see, okay, I can get an area of some geometric shape. We can generify, if you will, or there's a word for it, but basically make our class so generic that can really apply to a lot of different things, but we'll talk about that later. We don't need to be concerned with it now. Hey, where did my mouse go? Oh, never mind. It's like locked over here. All right, guys. And then the last section here, the last thing from 13.1 that we should have picked up. And again, there's a lot of good information. It just really summarizes the stuff about objects. But know this, like out of the box, in objects attributes, or those member variables, or those variables, member variables, they're going to be private by default. And the whole reason for that is so that we don't have code randomly in our program accessing those member variables and changing them. Like, we don't want to do that. And it's almost like we have to unlearn what we had learned before, which was we didn't even think about this. We're doing procedural programming, and you have pretty much access to that variable all the way through your code, right? So here we're kind of formalizing that in that we're protecting those, member variables. And there's multiple reasons for that. I mean, here you go. For data hiding, restricting the access to only certain members. Like, so that way you're not exposing all the data to everything in the program, because everything in the program, there may be like, the point would be is that then I could write some command or do some command and have access to some private data member, and I don't want that. So what you have to do, or what we do, is we create a public interface. And those are ways in which you can access that data, either by setting the value properly, so that way you can eliminate errors. You can do data validation and checking like that, because we, dipped our toes a little bit into that, but that's the whole point here. So again, that's why we have this structure like this, getting and setting. We formalize it so that way, we have like an interface into how to work with that object. I know that's a mouthful. Again, you want to read over Tony's stuff. That's what this section culminates to, and that's 13.1. Okay, so I didn't see anyone raise their hands. I don't think I get notified, but any questions with that? That's everything from 13.1. You know, again, this is like really cool stuff. I mean, this is what it's all about, you know, and I don't want to say what it's all about, but you know, fundamental stuff here, really important. Well, actually, it's intermediate, right? Because we talked about fundamental stuff in 105 and 205, and now we're like at, I don't even know what class this is, 315. So we're going to be talking about some more advanced stuff. Okay. So all that being said, here's our introduction to classes. And again, we went over this at the end of 205, but I really don't feel like we gave it any justice. This section all looks at the semantics of our class, you know, really looking at what it is. 13.1 was just like general overview. Now we actually look at some examples, right? All right, so here we go. Now, you know, we already said that, like, hey, our classes are going to be similar to structures, and sure, lo and behold, they are. As far as the, you know, the syntax is concerned, right? It's all the same. I don't want to say the official class definition, if you will. It's a data type defined by you, the programmer, consisting of variables and functions. That's what it comes down to, or methods, depending on what language you're talking about. Here's just a general format. You know, you have your class and then the class name, right? So the key word there obviously is class, where before, right? Anyone remember in the Wayback Time Machine what we would have had to have put there? If we were using structs, ADTs.
Struct.
Yeah, you would just say struct, right? So again, keyword class will tell me what it is. And well, I didn't see, yeah. So Jess and Stack, you might remember from 330, like we cue in on those keywords, and then based on that, we have to do something. But at any rate, I digress. So class name, now by convention here, you know, if you have a class name, you know, like we said, rectangle, you know, you would have, you know, it would be like capital. So that way we know what's a class. Then when I'm, you know, instantiating or I'm defining an object of rectangle, I know that if I see rectangle, and again, I should use, you know, I don't know. This is the blue rectangle. I really don't know. You know, something like that. I know, okay, my object is a blue rec, and, you know, it's of the class rectangle. So again, this is just convention. It's not anything that, you know, you need to set in stone, but very helpful if you do that. And this is not camel case. It would be the other one, right? Somebody would have to look that up, but it would be Pascal.
Upper camel
right?
case.
What is it?
It's also called upper camel case.
Upper camel case. Okay, upper camel case. So yeah, just again, you know, is it going to be life changing? You know, I may mention to you in one of your labs, but again, you know, I may take off a point. I don't know. But just, you know, follow the convention here. So here's a full-blown example, okay? And we'll look at some obviously beyond what's on the slides. But like we said, you know, in C++, by default, you don't have to use the word private. Any of those member variables are going to be hidden and can only be accessed by functions that are members of the same class. Now, I know that seems like a mouthful, right? But what we're saying is that these guys right here, even if you didn't say anything in C++, you're not going to have access to them. You're not going to be able to say, you know, you know, if I create an object and we said what, blue rectangle, if I say blue rectangle, you know, dot width, I don't have direct access to that like I do with a struct, right? With a struct, that's how we did it. That's how we set the values, right? No, 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 no. The only people that can access them are going to be those member functions that can access them, have direct access to them. Now, certainly you can override that. Certainly other classes could have access to, private, member variables. But hold on to that thought. We got to talk about friend classes and this kind of stuff. But what I don't want to say emphasize here, but what I want to point out is that the use of private and public. Now, it honestly doesn't matter which way you start, but this is, again, a convention. If you have your private listed first, and it's just like any other code, if we don't structure it kind of the same way, it starts to look a little messy. And maybe you have private, a couple public, and then you have private. You may have a reason to do that. I don't want to say I'm trying to think of an example, but I have seen it that way certainly before. But again, you just that key word there. The private versus public, those are called access specifiers. So, when we were just looking at the beginning of class, we were looking at access level, right? Basic, stakeholder, and this and that. These are just access specifiers. They tell us what these attributes are of our class. And they also specify how those class members may be accessed. Is it public or is it private? Because if it's private, we said that then, okay, set width here, it's only going to have access to, obviously, probably the width. That's what you would be passing it. All right. So a little bit more about that as far as the access specifiers. Again, it's really just summarizing what I just said. Used to control access to the members of that class. Public can be accessed by functions that are outside of the class, doesn't matter. Private, though, can only be called by or accessed by functions that are members of that class. And again, like I said, that's, I don't want to say not entirely true, but for now, let's just keep that in our mind. We'll talk about what the exceptions are, actually, I think a little bit later in this chapter. So, cool. And you'll have to do it on your assignments too. You'll have to do, yeah, we'll look at it. Okay. Again, here's an example that we've seen before with the class rectangle. I don't think there's much to be said here. Unless, again, if you have questions, if you're like, I don't know something, you got to talk to me, post a question, feel to, type it out. Mondo, you had a really good question yesterday about Max. Again, even if you just want to affirm what it is and you want to verbalize that, you guys are going to be doing it in your teams anyway. So when you guys are working together on your assignments, you're going to be talking to one another. And that's great. That's exactly what we want to do. I don't want to say you don't have to here because you're going to have plenty of time later. And like we said, there's no rule that says, you have to declare your private members before the public. Even though C++, that's different in some languages, but in C++ gives you that freedom, arrange them however you want. You should really kind of adopt some kind of consistent standard unless you really need to deviate from that. Most people will group them together. These are all the private members. These are all the public members, or public functions, private, so that's what we're talking here. Yeah, if you don't specify anything, the default's private, which again is different from our structs. Now, you may have noticed this. You see that const keyword after the parentheses in a member function declaration. The nice thing there, as you can see, it says get. So that that specifies that that function is not going to change any data that's stored in that calling object. And that's helpful, again, if you make this a public, right, member function, because then I know nothing's changing. When you're talking about data integrity, great, nothing's going to change inadvertently or otherwise, accidentally. If you do, let's say you put something in there like, I don't know, with plus plus, right? Your compiler, when the time comes to compile your code, you'll get an error thrown, right? Because it knows that it's a constant member function and it shouldn't change anything. So you'll see that. You'll see an error. Oh yeah, the goods. We get the goods here coming up. Now you're going to see this thing as this scope resolution operator, and these are just two colons is all it is. And when rectangle double colon appears before the name of a function in your function header, it's again going to define that, or it identifies the function as a member of the rectangle class, right? So again, scope resolution operator, you're defining set width, right, as a member function of the class rectangle. What's the problem with that function header, though? Or what? What do you think about that?
Should it not be capitalized?
Wait, what? Rectangle?
Yeah, rectangle.
Well, what is rectangle?
It's right.
It's
an
the name
integer.
of it. I was
It's the
thinking
name
that
of the class.
Name of the class, yeah. What were you thinking, Jess?
that if they're going to use a variable that is of the double type, they should either make their function or their class rather a double, or they should switch them around.
Well, and think about that a little bit. Yeah, you got this int here. What the heck is int doing? What's int doing there? int.
Nothing really. It should be a
Oh,
void
yeah.
function.
Okay, what was that, Parker?
I think it should be a void function since it's not returning anything.
Yeah.
It's
You're
setting
absolutely right.
something.
Yeah, that's what I wanted you guys to see. That this is, this is a mutator. Well, it's a setter function, right? So it's setting some value. You're passing it. You're not returning anything. There's no return statement in that function. So why am I making it an int? You'll see it makes sense not to have a data type there, because there's no point, unless you're returning some kind of error code or something. But even then, it's not listed here. So I bring that up because, again, these are slides from the publisher, so I didn't make these. But yeah, that's what it is. All right, so let's slip this. These terms, mutator, accessor. Now, these are just nothing more than more vocabulary or terminology. And all it boils down to is if that member function changes a member variable or it doesn't, right? You typically you're going to see these referred to as setters and getters, like they set, those, member variables, or they get the member variables, right? So if I get them, right, it makes sense. If I'm going to get them, that something like this, I'm going to have a return type. If I'm going to set them, probably void, I'm not going to return anything because I'm going to pass the value, right, to whatever member function I have. Cool. That's all it is. That's 13.2. So I think we need to, I don't want to say take a breath, but I would say pretend like you're eating something and you can take a breather from your mask, or not. I know, because again, all you have to do is like pretend you're eating something and you can take your mask off. Yeah. We have, it's supposed to rain tonight, but we're having a Cub Scout pack like movie night, and it's supposed to rain. So then we're like, well, we can move it into this big barn, but then we're like, oh, well, wait a minute. Then you got to worry about masks, right? And we're gonna have popcorn, so it's gonna be like, I want to say it's almost pointless in my opinion, but it's kind of like if the kids are going to be sitting there eating popcorn, they're not going to have their masks on, and then they're going to be breathing. So I don't know, man. But at any rate, for us,
Just tell them not to breathe when they eat.
Yeah, exactly. Just stop them kids from breathing. That'll take care of your problem.
Exactly.
or we could pass out like Meyer bags, and when they take a bite, they just put the Meyer bag over their head.
Oh,
God.
genius.
I don't think they'll be able to breathe that way either.
Well, then
Okay.
sure they're not breathing. That's so terrible, right? Can you imagine? Some parent looking like, why are you having our kids put bags on their head? It's for their safety.
For their safety.
Right. Oh, okay. As far as, I don't want to say class time. I don't know. I always lose track. But it looks like we have till 12:15. Luckily, we don't well, Ben and whoever else is in the lab, you have to wipe down your area. So I don't know, if you need to leave class a few minutes early for that. That's cool in the gang. And also, too, I mean, if you guys want to have a conversation with me about the need to be in the classroom, I know some of you brought that up last semester, like that was a big deal. Unfortunately, it's not going to work for some of us because of the quarantine business. But I mean, if you really find a need for that, we can work out something. Just let me know what you need, okay?
I just straight up didn't know that it was online, and I was already at school, so I figured
Yeah.
I'd stay here.
I was actually thinking about doing this at home, but I may do that some Fridays, where I just do this at home. But I have to be here anyway on Fridays for a 1:00 class, so it doesn't really matter to me. It's just a matter how quick I get ready, I suppose.
I don't have a webcam at home either.
Well, like I said,
phone.
you can, yeah, you can do the phone, and that's fine. I would do that too. I would just pop up the phone, prop it up.
That's what I'm doing right now. I have
Yeah.
this on my desktop that I have my phone, but I get my webcam Monday.
Be-
It's true.
because I was looking at the top 15 things to learn remotely or whatever, and one of the top ones was having at least 2 monitors. So you could have one up, join the Zoom, WebEx, whatever it is, and then another one up, so you could either
Pretty much.
work on stuff or watch YouTube videos or something, right? So that way, you can work. So yeah, I really got
I actually have
spoiled.
to.
I used 4 monitors over the summer, and I was absolutely loving it. I got so much stuff done. I mean, it was great.
That's awesome.
All right,
Yeah, having
guys.
amazing.
Here's the thing. Here's the next section, right here. So we're really up to 13.3. And if I am looking at the grand scheme of things, I really want to start looking at some examples. But overall, right, there's about 16 sections in this chapter. So it's jam-packed full of content. You're going to want to systematically go through it, read it until you find that you're not focusing anymore on what you're reading. Take a break, right, and then come back to it. That's what I have to do, because I find myself, reading, and then I'll be like, I'm not really reading it. I'm just looking at the words. Really, my mind's drifting, right? So
I had to skip the pointer part because it was making my brain melt.
Oh, yeah. Well, we have some examples for that. I don't have any examples, I don't think, for this beginning stuff, but yeah, we need to look at that, and I think it'll be clearer once we go through and we work through each of the examples. This is the whole reason, right? The pointer crap, the whole reason why we needed to be watching our variables and the values of them. The examples I have put together, I think it'll be very, I don't want to say clear, but I think it'll make a lot more sense. So we'll get there. Hang tight. All right. So what? Oh yeah, defining an instance of a class. So, again, the lingo, if you will, you sound really smart when you talk about this stuff. If you're like, well, my object, which is the instance of my class, is called this. And then people are gonna be like, oh, well, gee, you're really smart. We should give you a lot of money to work here. And that's what happens, right? As long as you can talk the talk. No. Yes. So what is it? Well, again, these are just like examples, kind of walking us, I don't say walking us, but really getting us into how to work with classes. So what? Now, if I do this, let me see. 2 and I got on the wrong thing here. Okay, so 2 and text, and I probably want to make this a little smaller. All right, so if I say r dot width equals 5, the question here is, what is r then?
Rectangle. It's the class, right?
It's a class.
It's the
It's the
object.
It's an
instance of it.
object, yeah. Object instance of a class.
Here's the thing. I'm sorry, it's a trick question.
No.
Because see how we're accessing that that variable? Do you see how we're accessing it? We're saying r dot width. Well, this is what we use for structures, right? So r actually would be a struct. And again, I show you that just to confuse you. No, this is what we had used before. So we would say r dot width equals 5. That's fine, we could do that. But what we said is out of the box, we don't have access to those members of our class. So this isn't going to work for us. We need to upgrade our thinking or upgrade our whatever to be able to use getters and setters. That's where you see that on this example. Notice that inside the rectangles class member, right, the class member functions down here, right, the dot operator is not used to access any of the class's member variables. When you have an object used to call a member function, the member function has direct access to that object's member variables. So again, when I say, something like this, I have access to whatever is part of that object. So if it happens to be width, I have access to width. Now, and again, this is where Michaela has said, I looked ahead and I looked at pointers and I'm like, WTH. Well, it has to do with what is the active object, what is being manipulated, what's being passed into, in this case, set width. Well, we already know what it is. It's going to be an instance of a class. It's an object. What is that object? And I don't want to jump ahead by talking about this and that pointers, but that's where we're driving. But again, the whole point here is set width. That function has direct access to whatever member variables are of that object are. Okay. Yes. So let's look at an example because again I say that's seems like foreign language there, but let's look at this, guys. So let's open up this bad boy. And again, you should have access to all these files, and I would recommend you go through them yourself. First off, I'm going to tell you this, that at this point, yeah, sure, this program demonstrates a simple class, but the thing about it is, looky how long this is, right? Where are we at? 92 lines? 92 lines of code? Well, you know, some white space, white lines in there and stuff. But do you see the benefit? Well, you will see the benefit. In 13.5 of the textbook, we're going to talk about how we break this apart, right? And again, this is kind of like a little bit of it's a review of the overview that we had in 205 at the very, very end. Okay, so at any rate, what do we want to do here? Well, we want to look at this stuff. So, you know, here's a good example. Rectangle box. So that's where, okay, we have this object called box. Now, do you see that the current object is box? Right, so that is the object that I'm dealing with. And what do I want to do with box? I want to set the width. Well, what do I want to set the width to be? Well, I'm going to pass it some value, right? So then I go to where set width, because remember, this is a member function of the object box, or it's a member function of the class rectangle, right? That's a better accurate description. So let's go look at set width. So what's set width doing up here? All right, we see that this is, you know, it's a W, and all we're doing was just saying width equals W. Now again, there's not any, you know, because we don't know what this is. Like whereas in a struct, we did know, right? So it's almost like it's abstract here. We have to assume it's the current object, right? That's really of that data type. So that's how we know where to go to find width. So where do we find width? Well, here he is up here, right? So do you see how we have access to that directly to that private member variable of the class rectangle? So again, that's how all that stuff works out. And you can see here by highlighting the word width, I can see where it's also, you know, specified or found, if you will. Okay, so again, hopefully you can draw the lines there, or, you know, connect all the dots. And you have direct access to it. You know, I'm not going to say withy because that's nothing. But now, if I put it to that and I mouse over it, right, you can see that, yeah, what is that? Well, rectangle colon scope resolution operator. And that's why the scope resolution operator is such a nice term, because you're resolving what the heck width is, because you know that it's basically, it comes from there. Okay, so that's where it's nice to be able to mouse over things, so that way you can start kind of putting the pieces together. Although you should be able to look up there and see that it's a class, right? Right. All right. So that gives us a little, you know, again, getting our feet wet, if you will, on working with classes. Oh yeah, well, we'll start this because there's a couple things here talking about pointers in a sec, and we need to spend some time with that. But let's look at this real quick. Any questions with this? Any questions with the example? Are you not seeing, getting? Do you want anything else explained a little bit? If you open up this example, it's very clear, you know, what is going on. And you need to be able to put these pieces together. If you're not, that means you didn't read the chapter and you didn't look at the examples yet. And that's fine, but you need to do that at some point, because the only thing really, quote, homework wise was, you know, to look at the team, you know, thing or whatever. Now over the weekend, you want to set aside some time to really read and get up to speed, because next Monday, you know, might be kind of a shocker as far as level of complexity and things that I'm asking you to know. Okay, So everybody's cool. Everybody cool? Or not? I know sometimes I'm almost like I talk and then it's like I almost make it seem like, well, if you say anything, that means you're a big poopy head. No, it doesn't mean at all. Not in the least. So, like I said before, I don't know everything. That's for 100% sure. And it is always helpful to kind of verbalize this. So, anyway, work through it, look through it, play around with it, trace it, put in your breakpoints, and then step through it. So you can see how every one of these nice little functions gets called, the value is getting passed, and see how you can work it. This is, again, very straightforward example. Okay. Yeah. So here's I don't want to say another point, but if you try and do what I initially illustrated, you will get a compiler error if you attempt to access private members using that dot operator. You're going to get that if you try and do that. So don't do that. And again, it's all, you can obviously circumvent that by, making these, member variables public and stuff like this. But, that's not the point. We want something well-defined and structured and followed by the rules. All right, guys. And then I don't want to say leave you on this note, but let's, well, there's this yet. Shoot. I don't know how much time we're going to have for this because there's a lot of stuff here. So, some data is the result of a calculation. Okay, great. What can happen then, let's say here, this in this rectangle class, the area of a rectangle is calculated by the length times the width. Well, what's going to happen if we were to use an area variable here in the rectangle class, its value would be dependent upon then what is the length and what is the width, right? If any of those two change and the area is not updated, guess what we have? We have a problem with that area is no longer accurate because either the lengths change or the widths change. So you have to make sure that you have a mechanism in place to not have stale data. And that's all that it's saying right here. You can see that in the last example, 13.1, and that's right here. The last, we don't have a member variable called area here, because if we did, guess what? It's going to be stale. So that's where we're going to have a function that's called getArea, because guess what it does when you call it? It's going to look at what the current value of width is and the current value of length is. There's no way we're going to have stale data at this point. But we'll always be able to get an area that's up to date and accurate. Okay. And again, it's just a member function, and it does nothing other than just calculating the area. Why? Because we don't want it to be stale. Okay. And the last couple minutes here. Let's look at this. And again, if you want to read over this section over the weekend, that's fine. But you definitely have to make sure you've read up to everything that we talked about so far. Here's the thing. You can actually define a pointer to an object, because all an object is just a bunch of space and memory. It's just an address, really, and it starts here and it ends there, right? So we can have a pointer to it. This first statement, rectangle, right, asterisk RPTR equals null pointer. Well, we know that before when dealing with pointers. That's kind of how we initialize them, right? You make a null pointer point to nothing. Now, the thing to keep in mind is that, yeah, that RPTR is not an object. It is not an object because it doesn't occupy a bunch of space in memory. It's really just an address that then points to the actual object. We are going to step through what that means. Definitely not today because we don't have enough time, but I just kind of want to give you an overview. Our pointer here is not an object, but again, it can hold the address of a rectangle object just like any other pointer. Again, all it is an address, right? So you can access public members via a pointer. Like our pointer is going to equal, the address of some object called other rectangle that's derived from probably the class rectangle, right? And if I do this, we know from before that is give me the address of, right? Give me the address of this object because I want to put it in to my actual pointer value. Then we talked about this before, our pointer, instead of using dot, I can use this nice little, I lost my mind on what the arrow is. There's a name for it, but at any rate, I'm saying, set length. So again, this pointer is whatever, it happens to be the other rectangle. So in essence, I'm typing the word other rectangle here. Now, and there's some reason for that. And we'll talk about that later. Why would I want to do this? Because passing around just an address is a heck of a lot more efficient than passing around the whole entire object, right? That's the whole point here of the pointers. So that's why we need to learn it. We need to know it. Okay. So again, that should be really confusing. And, I don't want to say you're going to hate it, but until you work with it enough, it's going to be confusing and difficult. So like I said, this is in section at the end of 13.3. So read over it. We will, I will have an example. I will walk through it next week on using pointers. I think it's going to help you know this. So we have 2 minutes, 1 minute left. We're down to the last minute. Okay, so guys, anything we need to really wrap up or anything we need to talk about? Yeah. Well, I'm going to keep recording this only because I don't want to mess up anything. Because I know if I switch stuff around, I know that if I switch control, give somebody else's screen, the recording gets like messed up. So I'm going to keep it on just for now so I don't mess up anything. Oh, speaking of that, I had noticed this. Let's do this. Let's kind of like end the recording, if you will. So I will do this by stopping recording. Okay.